I'm Anil Kumar, and now let us take a question on application of quadratic functions. One integer is 5 larger than the other. The product of two numbers is 104. Find the integers. So let us say that the integers are x and y. When we say one integer is 5 larger than other, that means we can say that the integers are x and x plus 5, or what I'm trying to say is y is 5 larger than the one integer. So these are different ways of understanding the question. Now we could use two variables or we can solve with one variable. I'll prefer to use one variable for quadratic functions. When say one integer is 5 larger than the other, let the integer be x. The other one is 5 larger than the other, so we'll use x plus 5. So that is for my choice, right? Or I could go this way. Let the integers be x and y. Y is x plus 5. So the two integers are x and x plus 5. Correct? So that is how we define our integers. So that is our variables. So variable in our case is single variable. Let the integer be x. Then the other is 5 greater than x, x plus 5. The product of two numbers is 104. That means x times x plus 5, that is the product, is equals to 104. That gives us the equation. Now, if we expand it, we get x squared plus 5x equals to 104. Now that is a quadratic equation. Let's bring 104 to the left side. We get x squared plus 5x minus 104 equals to 0. Now at this stage, you can do a couple of things. You can use quadratic formula, find the value of x. That is one way of doing it. Second is you can factor it. I know it's difficult to factor such questions, but let's try to do it, right? Application of quadratic formula is not difficult. Anyway, we'll try to factor this one and then do it. How to factor? We are looking for two numbers whose product is 104 with a negative sign and whose sum is plus 5. How can we get these numbers? So the technique here is prime factorization. I'll show you this technique here once again. 104, we can divide this by 2. So 2 times 52. 52 pack of cards can be distributed 4 in 13, right? So 4 times 13 is 52. Now you see, if I multiply these three numbers, we'll get 104. The idea is to have two sets so that sum is 5. Since the product is negative and the sum is positive, bigger number is positive, smaller number is negative. How about 13 and 8? That works, correct? So we can think about 13 and 8. Since we need positive sum, 13 should be positive, 8 should be negative. Right? So that makes it easier for us to factor this. So we can factor this as x plus 13 times x minus 8 equals to 0. Do you see that part? Now from here we can get our numbers. The number could be x equals to minus 13 and the other number could be x equals to plus 8, correct? So that gives us choices. So we actually have two set of answers for this question. So one set is, says one integer is 5 larger than the other, right? So if I use one integer x as minus 13, then the other is x plus 5, minus 13 plus 5, which is minus 8, right? So that is one set of solutions. The other one is, I could use 8 and the other number, right? So 8 and 8 plus 5 is 13, right? So these are also the solutions, right? So we have two sets of solutions here, right? So we have two sets of solutions. The numbers could be 8 and 13 or minus 8 and minus 13, right? So these are our solutions. I hope you understand and appreciate it. Now let me give you the quadratic formula here also, so that those of you who want, they can use the quadratic formula, which is x equals to minus b plus minus square root of b square minus 4ac over 2a, right? So in this particular equation, you know b is 5, so it will be minus 5 plus minus square root of b square, which is 25, minus 4ac, so minus 4 times a is 1 and c is minus 104 square root divided by 2 times a, right? If you solve this, you will get the same answers which we got, minus 13 and 8, right? So you can do that part and find your answer, right? But I hope with this example you learn different ways of solving a question and also a technique of factoring which we have discussed earlier also. Thank you and all the best.